Alright, you are welcome again. Today we are going to talk about proving identity. We are going to prove some identities in elementary algebra. Now let's take a look at them. We are asked to prove 1 plus sine x all over 1 plus cos x times 1 plus sec x all over 1 plus cosec x is equal to tan x. Okay, 1 plus sine x all over 1 plus cos x in bracket times 1 plus sec x all over 1 plus cosec x in bracket is equal to tan x. Then number 2, you say tan x plus cos x all over sine x is equal to sec x plus cot x. Okay, tan x plus cos x all over sine x is equal to sec x plus cot x. Number 3, so you should show that tan x minus sec x in bracket squared is equal to 1 minus sine x all over 1 plus sine x. And then lastly, we say sine a plus cos a in bracket times cot a plus tan a in bracket is equal to sec a plus cosec a. Please watch this to the end. Okay, let's do this. Please pay attention to this. It's very important, and make sure you watch this to the end. All right, most especially number 4. Okay, now let's go. Number 1, we say 1 plus sine x all over 1 plus cos x times 1 plus sec x all over 1 plus cosec x in bracket is equal to tan x. Let's work with the left hand side. So working with the left hand side, this second bracket where we have 1 plus sec x, sec x is actually the inverse of cos x. Okay, so let's write it the inverse of. So we're going to have in the second bracket 1 plus sec x is inverse of cos x. So we're going to write it like this: 1 all over cos x all over 1 plus cosec x is also the inverse of sine x. So inverse, we're going to say 1 all over sine x. Okay, so that means we are having 1 plus sine x all over 1 plus cos x in bracket, then second bracket 1 plus 1 all over cos x all over 1 plus 1 all over sine x. All right, now let's go. In this our second bracket, let's combine a numerator and a denominator. In a numerator, let's combine it. So that means we're going to have 1 plus 1 all over cos x. So when you add this together, you're going to have 1 plus cos x all over cos x. And then in a denominator, 1 plus 1 all over sine x. When you combine this together, when you add it together, we're going to have 1 plus sine x all over sine x. So that means we are having 1 plus sine x all over 1 plus cos x in bracket times 1 plus cos x all over cos x all over 1 plus sine x all over sine x. Okay, now in this our second bracket is complex. Let's reduce it like this. We can write it like this: 1 plus cos x all over cos x divided this big line, okay, all over is the same as divided by 1 plus sine x all over sine x. Okay, so in this second bracket, this division, when we want to perform division, we change the division sign to multiplication, and then we'll perform inversion. Okay, so inversion, the numerator we come down to denominator, and denominator will come up to numerator. Okay, so that means we are going to have 1 plus sine x all over 1 plus cos x in bracket. Then in that second bracket we have 1 plus cos x all over cos x. Instead of divide, we say times. So as we say times, so there will be inversion. So we have sine x all over 1 plus sine x. Okay, so we can put it in separate bracket, and then since all of them are all times, okay, so we have 1 plus sine x all over 1 plus cos x in bracket 1 plus cos x all over cos x in bracket sine x all over 1 plus sine x in bracket. Okay, now here we can see clearly that 1 plus sine x in a numerator, we can also find 1 plus sine x in a denominator, so they will cancel out. And then in a numerator also we have 1 plus cos x. Then in our denominator we are also having 1 plus cos x. They will also cancel out. So when these two are cancelled out in a numerator and in a denominator, we'll be left with sine x all over cos x. So therefore we're going to have sine x all over cos x, and then sine x all over cos x is the same as saying tan x. So therefore 1 plus sine x all over 1 plus cos x in bracket times 1 plus sec x all over 1 plus cosec x is equal to tan x. So we say hence the proof. Now let's take the second one. The second question says tan x plus cos x all over sine x is equal to sec x plus cot x. Okay, now let's work with the left hand side. So this tan x, we can say that tan x is the same as saying sine x all over cos x. Okay, so we're going to have sine x all over cos x plus cos x all over sine x. All right, good. In a numerator, let's join them together. Let's do what? Let's join them together. So when we join them together, we'll look for the LCM. LCM will give us cos x. So cos x divided by cos x will give us 1. 1 times sine x will have sine x plus cos x divided by 1 is cos x. Cos x times cos x will give us cos squared x. Okay, so sine x all over cos x plus cos x will give us sine x plus cos squared x all over cos x. So we have with this is just our numerator. All over our denominator is sine x. Okay, now we can also rewrite this and say that it can be written like this: sine x plus cos squared x all over cos x divided by sine x. Okay, now we'll change the division to multiplication and then there will be inversion. So we're going to have sine x plus cos squared x all over cos x times, so in this we have sine s, so when we invert it we're going to have 1 all over sine x. Okay, now let's multiply. Sine x plus cos square x times 1 to give us sine x plus cos square x all over cos x times sine x. We just have cos x sine x. Okay, now in this place we are having sine x plus cos square x all over cos x sine x. We can split this into 2. So when we split this into 2, we are going to have sine x all over cos x sine x plus cos squared x all over cos x sine x. So these two terms, they are the same. So when you combine them together, it's still going to give you sine x plus cos squared x all over cos x sine x. Okay, now let's go. We have sine x all over cos x sine x. Sine x in a numerator divided by sine x, it will give you 1, and then divided by sine x in a denominator, it's going to give you 1 times cos x. So we're going to have 1 all over cos x remaining. Okay, now in our second side we have cos squared x. So one of the cos x we cancelled, 1 under, that is 1 cos x in a numerator, we cancel cos x in a denominator, so we'll be left with cos x in a numerator and then sine x in a denominator. So we are going to have 1 all over cos x plus cos x all over sine x. Then you discover that 1 all over cos x is the same as sec x. That is 1 all over cos x is inverse of cos x, and the inverse of cos x is sec x, plus cos x all over sine x is also inverse of tan x. it will say that tan x is sine x all over cos x. So the inverse of it will give you cos x all over sine x. Then the inverse of tan x is cot x. So our final answer will say sec x plus cot x. So we discovered that tan x plus cos x all over sine x is equal to sec x plus cot x. We say hence the proof. Now let's go number 3. So number 3 we have tan x minus sec x in bracket squared is equal to 1 minus sine x all over 1 plus sine x. Alright, we say that tan x minus sec x in bracket squared is equal to 1 minus sine x all over 1 plus sine x. So let's work with the left hand side. That is, working with the left hand side, we have tan x minus sec x in bracket squared. So let's open this bracket into 2. Okay, now that means we're going to have tan x minus sec x in bracket, and then tan x minus sec x in bracket. Let's multiply. So we're going to have tan x times tan x is going to give us tan squared x, and then tan x times minus sec x in the other bracket is going to give us minus tan x sec x, and then minus sec x in the first bracket times tan x in the second bracket is going to give us minus sec x tan x. Then minus sec x times minus sec x in the other bracket is going to give us sec squared x. Okay, so let's go. When you look closely, you discover that minus tan x sec x minus sec x tan x, they are the same thing. So we can just have them 2 of it. So we'll say tan squared x minus 2 of tan x sec x. Hello. So we discover that we are having tan squared x minus, this tan x sec x minus sec x tan x is just 2, the same. Okay, so we're going to have minus 2 of tan x sec x plus sec squared x. Is that true? Yes. Now let's go. We can simply, let's rearrange. Let's take the last term to the front and then the front term to the back. Okay, that means we're going to bring sec squared x front and then take tan squared x to the back. Okay, so that means we're going to have sec squared x minus 2 tan x sec x plus tan squared x. Okay, now this sec squared x is inverse of cos squared x, so we are going to write it 1 all over cos squared x. It's still the same with sec squared x. Okay, we have minus 2 open bracket. This tan x can be written as sine x all over cos x bracket, and then this sec x is the same as 1 all over cos x. So we have minus 2 times sine x all over cos x times 1 all over cos x is still the same, plus this tan squared x is the same as saying sine squared x all over cos squared x. All right, yes. Now let's go. We have 1 all over cos squared x minus, in this center term we have sine x times 1 is going to give us sine x, and then cos x times cos x is going to give us cos squared x. Then we have plus sine squared x all over cos squared x. Now let's go. Have 1 all over cos squared x minus, now let's use these 2 to open. I'm going to say 2 times sine x is going to give us 2 sine x all over cos squared x plus sine squared x all over cos squared x. Now here you discover that the 3 expressions we are having, they have the same denominator. So when we combine these together, we're going to have 1 minus 2 sine x plus sine squared x all over cos squared x. Okay, we'll combine them together, this is what we're going to have. When you say 1 all over cos squared x minus 2 sine x all over cos squared x plus sine squared x all over cos squared x, since they have the same denominator, we'll just add their numerator. Okay, so we have 1 minus 2 sine x plus sine squared x all over cos squared x. Is that clear? Yes. Now let's see what we're going to do again. These are numerator. Let's take for instance, we have something like x squared minus 2x plus 1. X squared minus 2x plus 1. We can factorize this, right? So when you want to factorize this minus 2x, you say it's going to give you x squared minus x minus x. So when you factorize it, it's going to give you x minus 1 in bracket x minus 1. It's going to give you what? X minus 1 in bracket x minus 1. So when you put this together, it's going to give you x minus 1 squared. Okay, x minus 1 squared. Likewise, this 1 minus 2 sine x plus sine squared x, so it's the same, or when you factorize this, it's going to give you 1 minus sine x in bracket raised to power 2. So when you factorize 1 minus 2 sine x plus sine squared x, it's going to give you 1 minus sine x in bracket squared all over. We have cos squared x. So, in one of our formulas, we say that sine squared x plus cos squared x is equal to 1. So when you make cos squared x the subject, we're going to have 1 minus sine squared x. So in place of cos squared x, we replace it with 1 minus sine squared x. Okay, so now this 1 minus sine squared x, we just open this into two places. That means we're going to have 1 minus sine x in bracket times 1 minus sine x in bracket, and then this are denominator 1 minus sine squared x. You simply say is different of 2 squared. Different of 2 squared. So that means we're going to have 1 minus sine x times 1 plus sine x. So when you multiply this 1 minus sine x times 1 plus sine x, is going to give you 1 minus sine squared x. And then when you say 1 minus sine x times 1 minus sine x in our numerator, is going to give you 1 minus sine x in bracket squared. Okay, good. Now in this expression we are having, which is 1 minus sine x in bracket times 1 minus sine x in bracket all over 1 minus sine x in bracket times 1 plus sine x in bracket. So 1 minus sine x in our numerator will cancel 1 minus sine x in our denominator. So we'll be left with 1 minus sine x all over 1 plus sine x. Hello. So we'll be left with 1 minus sine x all over 1 plus sine x. So we'll discover that tan x minus sec x in bracket squared is equal to 1 minus sine x all over 1 plus sine x. Hence the proof. All right, yes, let's take the last one, which is sine a plus cos a times cot a plus tan a is equal to sec a plus cosec a. Hello. Yes. Now let's go. Working with the left hand side, we have two brackets. Let's multiply these two brackets. So we're going to have sine a in the first bracket multiplied by cot a in the second bracket. We're going to have sine a cot a. Then sine a in the first multiplied by tan a in the second. We're going to have sine a tan a. Now we have cos a in the first multiplied by cot a in the second. We're going to have cos a cot a. And then also cos a times tan a in the second. We're going to have cos a tan a. All right, yes. So we are having sine a cot a plus sine a tan a plus cos a cot a plus cos a tan a. All right, good. Now In this place, we have sine A cot A. So cot A is the same as saying cos A all over sine A. So let's put this in bracket because we have sine A times cot A. So then we say that cot A is the same as cos A all over sine A. All right. So let's put this cos A all over sine A in bracket because it is multiplication. Okay. Now let's go. Plus, we have sine A tan A. So tan A is the same as sine A all over cos A. All right. Let's put it in bracket because it is multiplication. Now we have plus cos A. This cot A is also the same as cos A all over sine A. Let's put it in bracket also. Plus cos A tan A. Tan A is the same as sine A all over cos A. All right. Now let's go. So that means we're having sine A multiplied by cos A all over sine A in bracket plus sine A open bracket sine A all over cos A close bracket plus cos A open bracket cos A all over sine A in bracket plus cos A open bracket sine A all over cos A. All right, good. Let's open the bracket. Let's use the value outside to open the bracket. So in this place we have sine A times cos A. It's going to give us sine A cos A all over sine A. Then we have plus. When you say sine A times sine A, it's going to give us sine squared A all over cos A. Then we have plus. Cos A times cos A is going to give us cos squared A all over sine A. Plus cos A times sine A is going to give us cos A sine A all over cos A. All right. Now let's go. We put all in bracket, right? Good. Now in the first bracket, we have sine A cos A all over sine A. So sine A in a numerator will cancel sine A in a denominator. So we'll be left with cos A. All right. Good. Let's go to our last bracket. We have cos A sine A all over cos A. So cos A in a numerator will cancel cos A in a denominator. So we'll be left with sine A. So therefore we'll be left with cos A plus sine square A all over cos A in bracket plus cos squared A all over sine A in bracket plus sine A. Alright? Yes. Now let's join them together. Let's add all of them up. Let's add up. So the LCM is going to give us sine A cos A. That means we're going to say cos A times sine A. We're going to have our LCM, okay? So we're going to say that our LCM is sine A cos A. So in this place, we should have, let's have something like cos A all over 1. And then in the last time, we have sine A all over 1, all right? So when you say sine A cos A divided by 1, it will give you sine A cos A. And then this sine A cos A multiplied by cos A is going to give you sine A cos squared A. Hello. When you say sine A cos A multiplied by cos A is going to give you sine A cos squared A. Then we have plus. When you say sine A cos A divided by cos A is going to give you sine A. So sine A multiplied by sine squared A is going to give you sine cube A. Okay, good. Plus sine A cos A divided by sine A is going to give you cos A. And then cos A times cos squared A is going to give you cos cube A. Plus sine A cos A divided by 1 is cos A sine A. And then times sine A is going to give you sine squared A cos A. Alright, good. Now, we have sine A cos squared A plus sine cube A plus cos cube A plus sine squared A cos A all over sine A cos A. Alright, good. Now let's go. We have sine A. This cos squared A is the same as saying 1 minus sine squared A. Alright, good. Now we have sine A, open bracket, 1 minus sine squared A, because this 1 minus sine squared A is the same as cos squared A. Now we have plus sine cube A plus cos cube A plus. This sine squared A is the same as saying 1 minus cos squared A. So let's put it in bracket, then cos A outside. Okay, now let's go. We have all over sine A cos A. Now let's go. Let's open this bracket. Okay, we say sine A multiplied by 1, it will give you sine A, and then sine A multiplied by minus sine squared A is going to give you minus sine cube A. Then we have plus sine cube A plus cos cube A plus. Now in this place we use cos A to open the bracket. We say cos A multiplied by 1 is going to give us cos A. Then cos A multiplied by minus cos squared A is going to give us minus cos cube A. Alright, all over sine A cos A. Now you discover that in this expression we are having sine A minus sine cube A plus sine cube A plus cos cube A plus cos A minus cos cube A. So now minus sine cube A plus sine cube A, it will give you 0. Alright, now cos cube A minus cos cube A, it will give you 0. Alright, good. So in our numerator we will be left with sine A cos A. So that means we're having sine A plus cos A all over sine A cos A. So we can also split this into 2. So in splitting it into 2, we're going to have sine A all over sine A cos A plus cos A all over sine A cos A. Alright, so sine A in our numerator divided by sine A to give you 1, and then sine A in our denominator divided by sine A to give you 1. 1 times cos A to give you cos A. So in the first side we're going to have 1 all over cos A plus cos A divided by cos A will give us 1, and then cos A divided by cos A is to give us sine A. That means the cos A will cancel out. Alright, so that means in the first side we are having 1 all over cos A plus the second side we are having 1 all over sine A, and then you discover that 1 all over cos A is the inverse of cos A. So we're going to have sec A plus 1 all over sine A is inverse of sine A. So that means we're going to have cosec A. So therefore we're going to have sec A plus cosec A. Alright, so we discovered that sine A plus cos A in bracket times cot A plus tan A in bracket is equal to sec A plus cosec A. Alright, you say hence the proof. Yes, thank you very much for watching. Please keep watching and then subscribe if you have not done so. Alright, see you next time. Let's take more example.